Topic is about atomic structure, and we got a confusion that is regarding the shell, orbit, subshell, orbitals, and electrons. What is the very basic difference among all these, and what is the basic concept? So today we'll talk about this very basic concept. So let's start over this basic concept from this particular diagram, and we'll relate these points with this diagram. Okay, just concentrate. You will get entire lecture in a very easy peasy way. Well, what is the first thing? That is shell or orbit. These two are actually similar kind, you can say, having a similar concept. So shell or the orbit. Here we have the nucleus, and the nucleus we have what? Surrounding the nucleus there is a shell. So here we have a nucleus, or surrounding it is a shell, and in that shell we have another such kind of portion which is called as subshell. And in that subshell there is further a kind of division available, a kind of portions available, a kind of parts available, a kind of chambers available. Those are called as what? Those are called as orbitals. And in those orbitals there are electrons. What? Electrons are there. Very simple. We have shell or orbits, in that there are the subshells, in that there are the orbitals, and in the orbitals there are electrons. Simple. Nucleus, shell, subshell, orbitals. In the orbitals there are electrons. So here we have our diagram, and from here we will start our next part of the discussion. So I have actually divided the entire lecture into 1, 2, 3, 4 portions. So now let's come towards the second portion. Here, a concept is going to be cleared a little bit more. Okay, so here you have the very first shell, that is the K shell. Sure. K shell. In the K shell we have a subshell, known as S subshell. So we have actually number of subshells available and number of shells available. So now what is the number? We'll talk about that a little bit later. First of all, let me give you the concept of this portion first of all. We have the K, which is a shell, and in that there is a subshell known as S subshell. So here is the very first shell known as K shell. In that there is the very first subshell known as S subshell. And in that there are actually two portions available, two chambers available. Those are named as orbitals. And in those orbitals electrons are there. Remember, the number of chambers are actually telling you about the number of electrons available in that particular subshell, or in that particular shell, you can say, in short. In this shell we have, in K shell, we have one orbital, and in that we have two portions, two chambers, and in those two chambers there are actually two electrons available. So in short, in K shell we will get two electrons. We'll further clear this concept. Just for now, concentrate this particular portion. I hope it is clear. K is the shell, and in that shell there is a subshell known as S subshell. In that there are the orbitals, there are chambers. In those chambers there are actually electrons. And how many electrons are there? Two. Why? Because in this particular S subshell there are two chambers available, in short. Now a question rises is that how many subshells are there, how many shells are there? Very simple answer. Shell is equal to subshell. Means they are actually a kind, you can say, directly proportional. You can write here directly proportional. When we are talking about the first shell, so we will be talking about actually the first subshell. So as you increase the number of shells, likewise there will be the increase of the subshells. Like one shell, one subshell, two shell, two subshell, second shell, two subshells, third shell will be having three subshells, fourth shell, four subshells. So like this, the number of shells are increasing. Along with that, there is an increase observed of the subshells. Example, we have the very first shell known as K shell. The very first shell is K shell. In this shell we have a subshell known as S subshell. Then we have the L, second one. So second means two, which is actually the second shell. So second shell means two subshells. A kind of understanding, okay? So the second two subshells are there. The first subshell will be the S, the second one will be the P1. And in third, we are having the third shell known as M shell. In this third shell, there must be three subshells according to the concept of directly proportionality. Means if the shells are increasing, the subshells must be increasing. So we have the M. Here we got what? SPD, 3. Third shell known as M shell. 3 are the subshells known as SPD. I hope you are getting the point. and the same goes for the remaining N, O, P, Q, etc., etc. Got? The way the shells are increasing, the same way the subshells are supposed to increase. Okay. Now the next point that is going to clear your concept further about this topic, that is about the orbitals. I told you guys in the beginning, we have orbitals like S, P, D, F, and etc., etc. Keep on. So I'm just keeping this point till the I'm making this restricting a kind this lecture for till the F. I'm not increasing more because many basic those students, those who are actually learning the basics, they will get confused when I increase the number of orbitals or subshells, etc., etc. So we have shell, and subshells. So subshells are actually SPD. Okay. Now in each subshell we have what? Orbitals. Here I told you we have shell. In shell we have subshell. In subshell we have orbitals. In the orbitals we have electrons. Once again, we have nucleus, we have shell, and then we have subshell, and then we have orbitals in which there are electrons. I hope you're getting the point. So we got the concept K, the very first shell, S, the very first subshell, and in this we have one orbital in which we have two portions. So a single orbital is supposed to have two portions, two chambers, and each chamber there should be electron. So we got in the S, in the very first orbital, 2 electrons. Why? Because in the very first orbitals we have two portions, two chambers. So the next one is the P, which is this P subshell. Now in this P subshells, so we have first of all nucleus, shell, then subshell. So if the subshell is P, then how many orbitals will be there and how many electrons will be there? Simple. P is actually the second subshell, and it must be having 3 orbitals. How many? 3 orbitals. So P is equal to having 3 orbitals. Number 1, 2, 3. 3 orbitals are there. In each we will be having electron. 1, 2, 3, 4, 5, 6. In each chamber, in each orbital we will be having electron. So if there are 3 orbitals, it means there are actually 6 electrons in the P subshell. So now another point that is going to help you guys is very simple. Another logic that is simple. The way your subshells are increasing or getting the grade upward, like S, P, D, F, it is moving upward. Likewise, the orbitals will be increasing in a sequence of, that is, odd number. Like if the very first shell is having subshell is having 1 orbital, the second subshell will be having 3 orbitals. So 1, then we have 3, which is odd number. The next odd number is not the 4, the next odd number is 5, and then 6 is skipped because it is even number, 7. So like this odd number will be actually a kind increased. So increment will be in sense of odd number. Simple. Odd number 1, 3, 5, 7, 9, and so on. So you must increase the number of orbitals in an odd sense. So now another point that is going to clear the number of electrons, that is very simple. The number of orbitals, if you multiply the number of orbitals with the 2, you will get the number of electrons in the particular shell. So, well, first of all, let me tell you a point that is about the P subshell. So how many electrons are in the P subshell? Simple. P subshell has 3 orbitals. In each we have 2 electrons. So 3 orbitals are here, and when you go through the filling of the portion chambers, you will get 6 electrons. So in the P subshells we'll be having 6 electrons, and in the D we will be having 5 2s are 10 electrons, and in the F we'll be having 7 multiplied 2, you will get 14. So like this, what will you do? You will just multiply the orbitals with the 2, you will get the number of electrons. Now let's have another point that is going to help us further to understand the concept of electrons and orbitals, etc., etc. That is simple. The question is that how many electrons are there in the K shell? Question. Number of electrons in K shell. So K is number first, the very first shell. K is the first shell. So in the first shell we will be having 1 subshell, and in this 1 subshell we will be having 1 orbital, and in the 1 orbital we will be having multiply 2 means 2 electrons are there. So we will get how many? 2 electrons. So in K shell we will be having 2 electrons. Now here comes the next one, that is the second shell. So I told you the second number is actually for the shell also, and the same number will be used for the subshells also. So means that second shell will be having two subshells, 2 2 2 3 3 3. Number is going the same for this shell and subshell. So 2 is L. The number of second shell is L, the name is L, number is 2, and subshells must be again 2, that is S and P. So we got the concept here that in the S we have 1 orbital, and in the P we have 3 orbitals. So what will happen now? Add the number of orbitals, 3 in 1, it will become 4. Now multiply this with the 2. Why? Because in each orbital we will be having 2 electrons. So what are the numbers now? 8. In short, what we got now, L will be having 8 electrons. So there are 8 electrons in L. Let me solve for you the next one also, that is the M. The third shell, M, now is M shell. So it is the third, so there should be 3 subshells, S, P, D. Now S is having how many orbitals? 1. P is having 3 orbitals. D is having 5 orbitals. Now add all these together. 5, 3 and 1. 5, 6, 7, 8 and 1, 9. So 9 multiplied 2 equals 18. So we will be having 18 electrons in the M shell. Now it is up to you guys to tell me the number of electrons in the N shell in the comment box. So that's it all from my side.